My kids ask so many questions, and they're like, I love it. I just hear them arguing about math, and just makes a father who's a math teacher just so proud. All right, so this is going to be 12.6, and it's multiplication with polynomials. All right, so the very first thing it asks you to do is to multiply negative 6x parentheses 3x squared minus x minus 3. Now you could take this and do what we've been doing. So what would be your approach if you didn't know anything about multiplying? Yes. Good. And just keep going down, right? You would basically distribute. Perfect at that. That's actually what I would do as well. But I want to show you what some of my kids have been doing to help organize their information. Since this is a one-term polynomial, that makes it a monomial. And this is a three-term polynomial, which makes it a trinomial. I can make a 1 by 3 box. And what this does, it helps them go, all right, negative 6x goes right here. 3x squared would go here. Negative x would go here, and negative 3 would go here. So you could, yes, distribute. Or here, they find it easier to go, okay, well, this, I wish I could put my fingers up, but this times this, the result will go here. And then this times this, the result will go here. And then this times this, the result goes there, and you end up with a nice, clean, organized answer. So with that said, what is negative 6x times 3x squared? So we have negative 18, right? No, you're good. You're good. So that would give you a negative 18. But if we have an x times an x squared, we saw last week and a little bit today, what do I do with those exponents? When I multiply like bases, what do I do with those exponents? I got to add it. So what is x plus x, or what's x times x squared? Remember, there's like an imaginary 1 right here. So it becomes x cubed. Now, here is where students get mixed up. Adding and subtracting, did we do anything with the degrees? No, we just wrote it down as is. We just added the coefficients. With multiplication, you actually add the exponents. So you want to make this negative 18x cubed. So if I look at the next result, what would negative 6x times negative x be? So it'd be 6, because you're multiplying. So it'd be negative 6 times this imaginary 1 right here. Hold on. Put a 1 right there, imaginary. Change back. Oh. Orange. 1. The whole thing is in orange. Okay, hold on. Sorry. What about green? Okay. There's an imaginary 1 right there. So this becomes negative 6 times negative 1, which is a positive 6, because we're multiplying. And then x times x would be x to the second power, because you would have to add their exponents. So what's then negative 6x times negative 3? 18, good. X. And there was no x over here, so it remains the x. So there's your answer. So I get negative 18x cubed. If it's a positive result, we're just going to bring down a plus sign. And if it would have been a negative result, we would have brought down the minus sign. That's your answer. You're good? Mm-hmm. Mm-hmm. Good. So you could have just distributed it like that as well if you wanted to. That I'm good with that because that's what I grew up with. But I've noticed that my high schooler they like this because it's like organized to them, and so whatever you like. I'm not saying which one you have to do. We technically been doing this whole distributing thing all night and last week as well, so I'm good there as well. So with that said, try this one: 5x cubed parentheses 6x to the fourth minus 3x squared plus 12. And you can either do the distributing or try the box method. Either one works for me. All right. When you're working through it, start by multiplying the coefficients and then add the exponents and then move to the next one. All right. So which way did we do? Did we do distributing or the box? All right, that's fine. I'm going to show both. I'm going to show a distributing here so that you have a box example and a distributing example. And you can kind of base it off that. But this right here would need to be multiplied to this one. So 5 times 6 would be 30. X third times x to the fourth would be good because we would just add those exponents. So this becomes 30x to the seventh. Then move on to the next one. 5 times negative 3 x third times x squared. So x third times x squared. Good, because you would add the exponent. So 3 plus 2 would give me x to the fifth. And then 5 times 12, 60. And there's no other x there, so what am I going to do with this x cubed? There you go. Hmm? So there was no other x here, so the x cubed basically just drops down. I know we're coming close to time, but I do want to do one more, and this is one that you'll see a lot of. All right. So in a real quick, fast, and a hurry, you typically see things like this. 3x plus 3 times 4x minus 3. Typically, you always see binomials times binomials. And again, you can do the whole distributing to everything and then combining like terms, or you can attempt the box method. I do feel the box method is a little bit more organized. This time I have a binomial and a binomial. So instead of a 1 by 3 box, I'm going to make a 2 by 2 box. So I'll write the 3x right here and the 3 here, and then the 4x here and the -3 here. So then I know to multiply each one of these things. So 3x times 4x would be 12x to the second, because they both had one little one. And then 3x times -3 would be x, good. 3 times 4x, 3 times -3. Very good. So to write the final answer, you don't see orange, green. Very good. So there's 12x squared. I write that result down first. And then I'm going to add this diagonal. So what is 12x plus -9x? 3. So it becomes 3x. And then I'm going to write the last term. So -9. All right. To add, as long as they're like terms. Yeah, there are sometimes they'll try to trick you and they'll throw like a 4x squared in there, and then you just can't combine those. You just write them out. Mm-hmm. Yeah, absolutely. Yep. Highest degree first. All right, so that's all that I got for tonight. So I will finish a video on 12.6 and then do one for 7 and 8. 7 is actually more of this. There's some special cases where you can, if you see the pattern, it'll go by quicker. But if you don't see the pattern, this process still works, which I kind of like. And then 12.8 is division. So I'm going to show a video of long division. We do not do synthetic division in this. That will be something you'll see in college algebra if you go to that one. It's a quicker way to do long division, but only works in certain situations.